This is our list of structures that end up overall electron withdrawing when attached to a benzene. So these are going to be pulling electrons away and deactivating and making aromatic substitution reactions go slower, right? So remember, if we're reacting with an electrophile, we want our ring to be more negative. So pushing electrons into that ring should make it more favorable and more reactive. Pulling electrons away is going to be unfavorable. And so there's a whole video on the halogens where these are electron withdrawing groups, mostly because of that inductive effect. They were also unique in that if you did do a reaction of benzene that had a halogen on it, they were ortho and para directing and overall deactivating. Right, so they slow things down. If the reaction does happen, it goes in the ortho-para positions. These are all electron withdrawing groups as well. What do you notice that are two similarities here? Right, so if we're looking at structures overall, there's a variety of things you can see there. Well, some have a positive charge, right? So if you have a positive charge next to the ring, right, electrons would generally want to be flowing towards that. They'd be pulling electrons to it. And also a lot of double bonds as well. Right, so looking at the adjacent atom has a double bond to an oxygen. It could be a nitrogen as well. So looking at a functional group like an amide. Right, but some sort of similarity like that, right? So our atom next over has a double bond and then a more electronegative atom. That's one of the things that those have in common, right? So whereas with our donating groups, we had a lone pair of electrons on that adjacent atom, here we don't. There still is conjugation here, right? So we've got electrons shared throughout benzene, of course, it's aromatic, so that resonance is good, but we can share those electrons throughout more of that structure as well, right? So we've got some lone pairs, we've got some resonance, a lot of electron sharing here. What direction is that electron sharing going to go? Well, probably towards the more electronegative atoms, right? So these resonance structures would be drawn in this way. We're pulling electrons out of the ring in all these cases. Right? The electrons are going to flow out of these ring systems, and that's going to make the benzene electron deficient. That's going to slow down the reaction, right? So these are electron withdrawing by resonance. Here's electron withdrawing by induction. We get sort of a combination. Inductive withdrawing here, we can't draw some more bonds here without breaking something, right? But the positive charge on the nitrogen makes that super electronegative. It's going to pull those electrons toward itself as well. Right, so these will deactivate the reaction, slow them down by withdrawing electrons out of the rings.